When we spend $1 trillion, that's $10,000 per family in the United States. And if you're spending that money and not getting any benefit at all for it, that's a terrible waste.
My guest today is Bruce Everett.
I have a PhD in economics, and I've been working in the energy industry for about 50 years now. I started out with the U.S. government in the early days of what was known then, 1970s, as the energy crisis. I spent most of my career as an executive with ExxonMobil. And after I retired, I taught for 15 years at the Fletcher School at Tufts and at Georgetown School of Foreign Service. I taught energy economics. And most recently, I've been serving on the board of the CO2 Coalition, which is an organization dedicated to getting science and economics of climate right. So let me just start out, Tom, by saying that Mark Twain supposedly said, it's not what you don't know that gets you in trouble. It's what you know for sure that ain't true. And this is a perfect quote, I think, for the climate debate. So what I'd like to do is to talk about 6 things that people generally know that just ain't so. The first one is that there's a climate emergency. This is a largely political statement that people use to shut down debate. And what I hear all the time is, no time for debate, time for action. It seems to me that anytime you've got a serious problem, you really want to have a robust debate. So let's go back to the beginning of this problem and take a look at what we're talking about. The real issue here is carbon dioxide and its effect on climate. Now, carbon dioxide is a beneficial, benign molecule. It's essential for all life, and it is not pollution. One of the most misleading things I hear is the term carbon pollution. The second thing that's interesting is people talk about the vast amounts of greenhouse gas that we put into the atmosphere. And if we look at this, CO2 concentration in the 1800s was about 0.03%. Today, it's a little over 0.04%. So what we're talking about is this tiny amount of carbon dioxide and its impact on the climate. This is another thing that bothers me. And virtually every article you see about climate shows a picture like this and talks about the vast amounts of CO2 we're putting in the atmosphere. This is steam. Carbon dioxide is invisible. So all you're talking about here is a picture of water. Not too much to worry about there. Now, it's also interesting to note that one of the things we do know about carbon dioxide is that it increases crop yields, helps plants grow, helps them be drought resistant. And you can see from satellite photos that NASA has taken what's known as the fertilization effect of CO2. And that's particularly true along places like the Sahara Desert. The edges of it have been greening up. And this is at a time when we need additional food supplies for very poor people in places like Africa. And I'd encourage your viewers to have a look at the NASA website and look at this. It's very interesting to see. Now, the original idea was that if you put CO2 in the atmosphere, you'll get some huge increase in the temperature, something like 3, 4, 5 degrees Celsius, that this would cause terrible problems. Now, in fact, we've been looking at this problem for 30 or 40 years, and these predicted massive temperature increases have just not materialized. We've seen an increase of about 1 degree Celsius in the last 120 years. It's not really much to worry about. Now, here's the problem. There's a lot of things that have an impact on climate. Variations in the sun, small changes in the Earth's orbit, volcanic activity, clouds, ocean currents, and yes, greenhouse gases. All of these things impact climate, but we don't understand them very well. And in fact, climate is too complex for simple answers. And unless you understand not only all these factors, but their interaction, it's very difficult to make climate predictions. Now, here's a critical point. The disaster predictions that we keep hearing are not based on empirical science. They're just artifacts of computer models. And these models have never been able to make very useful predictions. Now, I want to emphasize that science is one thing, and it's only one thing, and that's comparing ideas against empirical evidence. It doesn't matter how many scientists believe it. It doesn't matter how many committee reports you write. It doesn't matter how many computer programs you develop. If empirical evidence doesn't support your idea, it's not scientific. So, in my opinion, there is no climate emergency. So let's all take a deep breath and try to understand this problem a little bit better. Now, one of the things I find puzzling here is that the original idea was that CO2 would cause big temperature increases. The temperature increases would cause all kinds of problems. Now, even though the temperature increases haven't materialized, we're still seeing the argument that carbon dioxide has made natural disasters worse. This is one of the most misleading charts you will ever see. This was developed by the National Oceanographic and Atmospheric Administration, and what it shows is the number of natural disasters that cost over $1 billion between 1980 and the year 2020. And you can see that it's going up, and it's still rising. And the idea is that carbon dioxide must be causing these problems. Now, I've seen this chart on the Weather Channel. I've seen it on the CBS Morning News, and I've seen it in a number of other places as a demonstration of the seriousness of the climate problem. But let's look at this now. Since 1980, inflation has been by about a factor of 4. So if you had $100 damage in 1980, you could assess that at $400 in today's dollars. But that's not the real story. Since 1980, the number of houses in the United States has increased by 70%. And the median home value has gone from under $50,000 to over $300,000. So if we look at the value of all the housing stock in the United States, it's gone up by a factor of about 11 since 1980. So what that chart that I showed you is really measuring is not how many storms or floods or fires we have, and it's not their intensity. It's just the value of the stuff that's in the way. And that has increased so much that, of course, you're going to get more damage when you get a storm come through. All you have to do is think about, for example, what the Miami coast looks like today compared to what it looks like 100 years ago. And you'll see what this problem looks like. There's a guy named Roger Bilkey at the University of Colorado who he's a real climate guy, and he's a believer in the climate narrative, but he doesn't like the way that these costs have been assessed. So what he's done is he's gone back and looked at every hurricane on the U.S. East Coast since 1900 and adjusted it for the value of property that was there at the time. And if you look at this, what you see is the worst hurricane in U.S. history on a corrected basis was the 1926 Miami hurricane. The second worst was Katrina in 2005, and the third worst was the Galveston hurricane in 1900. There's no discernible trend in this at all. Now, if we really want to understand what's been going on in the world, let's not talk about property, let's talk about people. Now, this chart shows the annual deaths per 100,000 worldwide from natural catastrophes between 1900 and 2020. And what you see is a tremendous decrease. In the early decades of the last century, we had huge amounts of deaths from epidemics and from drought-induced famines. But since then, global agriculture has gotten much better, medicine has gotten better, infrastructure has gotten better, communication has gotten better. And in fact, global deaths from natural disasters are down 95+% over the last century. Now, the best estimates I've seen have been that there have been about 7 million COVID deaths out of a population of 8 billion. The Spanish flu that occurred in World War I and just after caused something like 10 to 20 million deaths out of a population of 8 billion. Much greater. So in fact, to me, this is one of the greatest accomplishments of the 20th century, is that we have dramatically reduced the number of deaths from all these natural disasters, and it's continuing to go down. Now, climate activists love to show pictures of starving babies in East Africa as evidence of the climate problem. But what you're really seeing there in these heartbreaking pictures are subsistence farmers subjected to constant warfare. And it's a terrible situation, but putting solar panels on your roof is not going to help those people. Now, the third myth is that renewable energy is less expensive than fossil fuels. I hear this all the time, and people say, well, I don't know about climate science, and I don't know about heating of the atmosphere. But wouldn't it be better if we just substituted this cheaper renewable energy for fossil fuels? Because after all, the sun is free, the wind is free. Isn't that better? Well, let's look at this in some detail. Here's my assessment. If we start out with what I believe to be the cheapest form of electricity generation in the United States, based on the data from the Department of Energy, we're talking about a natural gas combined cycle plant of about 200 megawatts. Cost about $230 million, and it would cover 1 square block. Now, you probably don't want that in your neighborhood, but it's perfectly suitable for a commercial area or an industrial area. And it would generate about 1.5 billion kilowatt hours per year at what I estimate to be about 7 cents per kilowatt hour. That would cover all the operating costs, the fuel, and give the investors a return on their investment. Now, let's compare that with an onshore wind facility of the same size, 200 megawatts. It would cost about 30% more, and it would take a huge amount of space, 13 square miles. That's why you see these things in the Midwest and places like Texas. You're not going to see them in Massachusetts. We don't have places like that. And the problem is it doesn't produce very much electricity, only about 0.6 billion kilowatt hours for a considerably greater investment. Now, in my estimate, that would cost about 8 cents per kilowatt hour. But that's not the real story. The problem is that the onshore wind farm doesn't produce electricity when you need it. It produces electricity when nature chooses to give it to you. And this is a very important point. Let's take, for example, as a comparison, the gasoline business. Companies make gasoline at refineries and they put it in a big tank. Then that's moved by ship or by barge or by pipeline to distribution centers near demand centers. And it's put in another big tank. And then tank trucks come up and fill up with gasoline. They bring it to your local service station and they put it in a tank. And then you fill up your car and you carry around a few days worth with you. And this system has enormous flexibility. So the refiner wants to know how much gasoline you're going to use over the course of a year, but he doesn't care how much you use over the course of a day or over the course of an hour. The system flexibility takes care of that without any difficulty. Now, electricity isn't like that. There's virtually no storage in the electric power system, which means the utilities have to generate precisely the amount of electricity you demand at an exact frequency and an exact voltage, second by second, over the course of the year. So this is a very much more difficult problem to deal with. Now, here's what I would suggest. One way of looking at this is, let's talk about an onshore wind farm, and we'll use the electricity that generates whenever it comes. But you have to have a backup for it. So let's build another 200 megawatt natural gas cycle just to use as backup for the onshore wind farm. Now, the wind farm robs the natural gas plant of about 40% of its revenue, but the natural gas plant still has to pay for its maintenance, and it still has to give its investors a return on their investment. So if you put these two things together, my estimate is that that would cost you about 9 cents a kilowatt hour, or about 30% more than just using the natural gas plant alone. So what are you going to do in this situation? Well, you can do one of three things. You can just put the burden on the consumer and tell them, sorry, you're going to have to pay 30% more for your electricity. Or you could subsidize the natural gas plant. That's not going to be very politically popular. Or what we're doing in many cases is just shut down the natural gas plant and hope for the best. And hope that you can operate the system with just the renewable energy. Now, if you want to get an understanding of the problem of this, look at Germany. Now, Germany's made a much bigger commitment than we have to renewable energy, both wind and solar. And what they've ended up with is a very unreliable electricity system with consumers paying twice as much for electricity as American consumers do. And I can tell you right now, German consumers are getting very fed up with this. they are not particularly pleased with the outcome of this renewable energy program. So I think we need to think long and hard about whether we want to go down this road. Now, right now, we don't have a lot of renewable energy, so it's not a big problem. We can manage. But the more renewable energy you force into the system, the more difficult this is going to be for the grid operators to give you the electric supply that you need at an affordable price. Now, if we go to offshore wind farms, it's much worse because these things are frightfully expensive. And my guess is that if you took an offshore wind farm of 200 megawatts with a natural gas backup, would cost you about 17 cents per kilowatt hour, which is 3 times or 2.5 times what natural gas would cost you. And we've just seen in the last week that 2 of the big projects offshore in New Jersey have been canceled. Basically for this reason, they're just too expensive. And I think the investors in those projects understood that they were never going to be able to supply consumers with reliable, affordable energy from those plants. So in my view, it's pretty straightforward. I don't think renewable energy is anywhere near competitive. Might be someday, but it certainly isn't today. Now, here's my 4th myth. The global energy community has united to reduce CO2 emissions. Now, it's interesting to see what happened when President Trump pulled us out of the Paris Climate Accord. There were howls of protest from the climate community that we were now stopping all this progress. Well, let's take a step back and see what's actually happened. First of all, where does CO2 come from in the world? Carbon dioxide mixes pretty well in the atmosphere. So unlike, for example, smog, which is a local problem, the amount of CO2 in the atmosphere over Washington, D.C. is pretty much the same as it is anywhere else in the world. Now, between 2000 and 2022, the U.S. and Western Europe worked hard to reduce carbon dioxide emissions. This is a big political issue in the United States and in Western Europe. And at a cost of what I would estimate somewhere around $1 trillion, your dollars, by the way, we managed to get 1 or 2 billion tons a year of CO2 out of the global system. So while we were fretting about this, what was the rest of the world doing? Well, they were doing this. China more than tripled their CO2 emissions. India increased theirs by 2.5, and the rest of the world increased theirs by about 30%. So the amount of CO2 that's being emitted in the world is much, much greater than it was in 2000. And we are, I would like to remind people, in the 8th year of the Paris Climate Accord, which was supposed to deal with this problem. Well, okay, we've just started this process of reducing CO2. What should things look like in the future? Well, it's interesting to note that the Energy Information Administration, which is the statistical arm of the U.S. Department of Energy, has just issued its latest International Energy Outlook through the year 2050. So this is just a couple of weeks old. And what it says is the United States and Western Europe are likely to keep chipping away at carbon dioxide emissions at very high cost. And this includes, for example, President Biden's Inflation Reduction Act. But what about the rest of the world? Just merrily going on their way, emitting all the CO2 that they want. Okay? Now, maybe China will level off, but India is growing very rapidly because both India and China are basing their economies on coal, the most carbon-intensive fuel source. So it's interesting. By 2050, according to the projection of the Department of Energy, India will be emitting more CO2 than the United States and more CO2 than Western Europe. Now, I find it interesting. Ever since the original UN climate agreement was signed in 1993, the UN has held what they call a conference of parties every year. They missed 1 or 2, but every year to plan out how to meet the targets of the United Nations for carbon dioxide reductions. So we've just had last November, COP27, which was in Egypt, and we're about to start COP28, which is in the United Arab Emirates. Now, these are not small groups of government officials sitting there talking strategy. There were 35,000 people in Egypt, and there are going to be an estimated 70,000 people attending this in the United Arab Emirates. Now, what happens at these conferences? Well, the developing countries make carbon reduction promises that they're never going to keep in return for large flows of money from the West that they're never going to get. And then everybody pats themselves on the back for their progress, and they go home and they wait for next year. And as you can see, this basically shows that carbon dioxide emissions are not going anywhere. Now, President Biden has pushed hard on electric vehicles. And the Inflation Reduction Act, by my estimate, may add 2 or 3% electric vehicles to our 250 million vehicle fleet. And if you look at the EIA's projection, they're saying basically 25% of the cars by 2050 be electric or hybrids or plug-in hybrids. 75% of the car fleet in 2050 will still be gasoline or diesel. But let's say we were able to magically convert the entire fleet to electric vehicles. This little red bar shows what the effect would be on total world CO2 emissions. So again, it's very important to remember where the CO2 is coming from. If you want to talk about CO2 emissions, don't go to Washington, go to Beijing and New Delhi. That's where the action is. Now, so why are countries not decarbonizing? They talk about it all the time. Well, the answer is because fossil fuels are the only economically viable source of plentiful, secure energy. Now, this has caused a lot of problems in the West because when President Biden took office, as a gesture to the climate community, he put all kinds of impediments on U.S. oil production, while at the same time encouraging other countries to increase their oil production because he wanted to make sure that the price of oil didn't skyrocket and cause problems for American consumers. So this is really quite a terrible dilemma he's gotten us into. For nearly 50 years, every American president has tried to reduce our dependence on foreign oil. And just when we had achieved that objective, President Biden came into office and threw it away. Now, there's no way of squaring this circle. If you're going to reduce fossil fuel production, it's going to cost you, and it's going to cost you dearly. If you're going to encourage other countries to produce the fossil fuels that you're not producing, you're right back in the national security problem that we had over all these years. Now, here's a related myth. The world is undergoing a transition from fossil fuels to renewable energy. I checked this morning. If you Google the term energy transition, you get 75 million hits. And everybody talks about this. We're on our way to clean energy. We're getting rid of fossil fuels. But is that actually true? Excuse me. Here's what's happened in the last 40 years. We started out using almost entirely fossil fuels. This is on a global basis, and we're measuring this in BTUs. And just for those of you who are not familiar with this, a BTU is the amount of energy that's required to heat 1 pound of water by 1 degree Fahrenheit. So it's a way of putting all the different energy sources on a common basis. Now, in the last 40 years, we've been pushing other renewable energy into the market, and nuclear energy around the world has been growing. But the world is still based on fossil fuels. And if you take away the alternatives, what you see is simply a steady, constant growth in fossil fuel use. Well, what does the energy information say about this through the year 2050? Well, they say same thing. We're going to continue to push small amounts of very expensive alternative energy like wind and solar into the marketplace. Most people are going to rely on fossil fuels for most of their energy use. It will still look like this. So yeah, the share of fossil fuels has fallen, but the absolute amount of fossil fuel used by the world just keeps going up and up and up. Now, I don't like to make predictions, but I think our grandchildren will continue to be basing their energy use primarily on fossil fuels. And the reason is that they're the only really reliable source of affordable energy in the world. Now, here's my last myth. And this is one that I've studied quite a bit. And I call this the Moonshot fallacy. You hear this all the time. If we can put a man on the moon, we can whatever. We can do just about anything. And this harks back to President Kennedy's 1962 speech of putting a man on the moon. Now, I happen to be a huge fan of the Apollo program. I thought it was one of the great accomplishments of the 20th century. Very inspiring. But let's remember what we did. We achieved a technically difficult feat a few times at great cost. We put 12 astronauts on the moon at a 2023 price of $15 billion per astronaut. Per astronaut. By the way, just as an aside, the picture you see on the screen is Senator Harrison Schmitt, who was the last man to set foot on the moon and was one of the founding members of the CO2 coalition. So I'll just put that in. Okay. So what we're talking about is doing something technically difficult a few times at great cost. But when we look at energy technologies, what we're trying to look at is something that we can scale up so that we can do it frequently at a very low cost. It's the exact opposite of what Apollo was able to achieve. So the moonshot is not the right model for commercial development. And I wish people would stop using this term. There are two corollary fallacies to the moonshot fallacy. One is that R&D can produce whatever we want. And for 50 years, I've been hearing people proposing energy policies that say, all we need to do is R&D and we'll get the following technologies and we'll be home free. The second one is by scaling up inferior technologies, you can make them good. And it turns out neither one of these things is true. Now, I can recall back in the early days, the emphasis was put on nuclear power. We would eventually have nuclear power that was too cheap to meter. It would just be like your cable. You'd pay a flat fee, you get all you wanted. That was the basis, by the way, of President Nixon's Project Independence. We had synthetic fuels, which was a big program under Jimmy Carter, where we'd make a huge amount of fuels out of coal and out of shale and out of natural gas and other things. Fusion. During the 1980s, there were many people who felt we'll have commercial fusion by the year 2000 without any problem. So all we need to do is find a way to transition between now and the year 2000, and then we reach this kind of energy nirvana. Well, didn't happen. President George W. Bush was a big fan of cellulosic ethanol, talked about it in one of his State of the Union messages, and he talked about how we would make it commercially viable. There still isn't any commercially available cellulosic ethanol on the market today. It's simply too expensive. Well, another favorite of President Bush's was hydrogen fuel cells. And you can see a few of these cars driving around, but hydrogen is a very expensive problem. Hydrogen is the most common element in the universe, but it doesn't come in pure form. It comes bonded to something else. In order to get hydrogen you need for fuel cells, you have to break that bond, and that takes a lot of energy. So we haven't found a way of making hydrogen in any way economically. And although, as I said, you'll still see a few of these cars driving around on an experimental basis, it's not something that's worked its way into the commercial area. Now, we got two more that are today's game changers. One is batteries. Electric vehicles are simply too expensive today for the average consumer. They're heavily subsidized. A lot of people like them because they're cool. Surveys show that most of the electric cars in the United States are bought by upper middle class California males who like to drive them around, but they are not affordable for the average consumer. And the reason is that the batteries are just too expensive. Now, I keep hearing people say, yeah, well, we'll just do some research. We'll get commercially affordable batteries and we'll have the problem solved. People have been researching batteries for 100 years and they are better, but they're not good enough. The second one is called carbon capture. You often hear the term net zero by 2050, net zero by 2035. And this basically means we don't have to get our carbon dioxide emissions down to zero, but whatever emissions are left have to be captured and re-injected into the ground. And that'll give us zero additions to atmospheric carbon dioxide. Now, the problem with this is we don't know how to do it. There's a lot of research underway, but this takes an enormous amount of energy. And what you don't want to do is generate energy and then use that energy to put the carbon dioxide emitted from the energy back into the ground. So maybe this will happen, maybe it won't. But as far as I can tell, these things are not ready. Now, we have to remember that technologies can be deployed when they're ready, but not before. They can't be magically brought into the scene. We have a lot of experiences in history in which technologies were so good that they deployed very quickly into the marketplace. One of them, for example, was diesel locomotives. It took only a few years for diesel locomotives to replace steam engines in America's railroad fleet because they're that much better. Second one, for example, is jet engines. We switched the aircraft fleet from piston engines to jet engines very quickly because jet engines are cheaper and they're better. Same thing, for example, would be true with iPhones. iPhones are cheaper and better than having a computer and a long-distance landline in your house. And you don't need the government to proliferate these technologies when they reach the point where they're good enough. What government often tries to do is to push technologies that aren't ready into the marketplace. And congressmen, of course, love to go in front of a manufacturing facility in their district and show what they've got. And this is, of course, the famous cylinder case. And we're wasting a great deal of money and a great deal of effort. Now, I am a firm believer in research, and I think government research is important because the government can do things that private industry doesn't do. But what research does is it tells you what you can and can't do. It doesn't allow you to do things that you can't do. So this is something that we really need to bear in mind. So my forward look on this is that we don't have a climate emergency. There's no need for anybody to be worried. There's no need for us to frighten our children every day when they come home from school. I think the world is doing just fine on fossil fuels and will continue to do that. And the real question in my mind is, how long will American consumers put up with wasting billions of dollars on useless alternative energy before they finally give up? I think this is, we need the money for other things. We have a lot of work that we need to do in the United States. And the hundreds of billions of dollars that we're throwing away on alternative energy and related kinds of issues is doing us no good at all and carries no benefit. So when we reach that point, we'll be back on track.
That was great. A lot of sanity in a small amount of time. I enjoyed that. Thank you.
My pleasure.
So I'm curious if you have contacts still in Exxon and if you think that a lot of people inside of Exxon actually believe in this climate hysteria, or why aren't they pushing back publicly against it more than they are?
Let me just first of all say, I don't have any inside information, but here's my sense of what's going on. When I was working at Exxon in the late 90s, early 2000s, we had a CEO named Lee Raymond, and he believed very strongly that the climate hysteria was wrong. It was scientifically wrong. And he wanted the company to say that loudly and to say that frequently. And we did. And the net result of that was we kind of painted a bullseye on the company's forehead from all the environmental groups. And when Lee retired and Rex Tillerson came in, people remember Rex because of his appointment as Secretary of State. I think Rex decided, I don't want to do that anymore. We're just going to not talk about it. And that didn't help very much. Exxon had already set itself up as the climate villain. So when our new CEO came on board, I think he said, well, I don't believe this any more than anybody else, but let's try to divert attention from us by saying, okay, yeah, we'll get on board. We'll reduce our carbon dioxide emissions. We'll support the Paris Accord. We'll do all these kinds of things. And, I don't like this, but I understand it. He's looking for the shareholders' interest. I don't think this is a particularly honest thing to do, but it's what they do. So I can't blame them for it. And I also don't think we're going to convince them to do otherwise. They're a commercial outfit. They operate on a commercial basis. They're not out there to save the world.
Okay, very good. Just how about in academia also? You have a lot of experience there.
I do.
Do you have a sense that people are just all in on the whole climate hysteria there? What do you think?
They absolutely are. And it's an interesting process to see how this has happened. I think there are a couple of reasons for it. One is there are a lot of people in academia who believe this. I'm not sure how many scientists do, but a lot of people do. And a lot of people who believe in a command economy. And they believe that the government should be managing the economy and they could make it better and fairer. And they see this as a way of getting to that end result. Now, what we've done to really make this problem worse is that the US government has spent, I don't know, tens of billions of dollars, maybe upwards to $100 billion in the last 30 years on climate research, all of which is designed to support the climate narrative. Now, today in academia, if you want to get a job, say, as a physics professor, you need to bring your own funding. Well, it's very hard to get funding if you don't get it from the government. And if the only funding that's available from the government requires you to be a supporter of the climate agenda, what's going to happen is academia is going to fill up with people who either believe the climate narrative or are willing to say they believe it in order to get their hands on the money they need to keep their research going. I think most people who try to go into academia who don't believe in the climate narrative will choose something else to study. If you today, if you speak out against the climate narrative in academia, it's likely to cost you your job. Now, I will say this. When I taught up at the Fletcher School at Tufts, my course was called Petroleum in the Global Economy. And the basic course was teaching students about how the petroleum industry works. And I had 14 weeks of 2 hours a week. That's 28 hours. And I spent 1 hour talking about climate change. And for a number of years, I had an annual debate with my colleague from the environmental department on climate change. It was very popular with the students and very well attended. Well, he retired and his successor decided there wasn't going to be any more discussion of climate. And I was asked to teach my course anymore.
Those debates aren't online anywhere, are they?
No. Well, as a matter of fact, yes, they are. Some of the older ones are online, and they were a lot of fun. And this colleague of mine, whose name was Bill Moomaw, is a climate advocate, but he's a firm believer in debating the issue. And he's a firm believer in having a nice civil conversation about it. And we demonstrated to students, I think, that you can talk about this and you can still be friends and you can have very, very different views. But unfortunately, you'll almost never find this anymore on a college campus. And that's too bad because one of the ways that you get these myths that I just talked about is that nobody hears the other side. So particularly kids these days go to school and this is all they hear. One thing that troubles me is that in many school districts around the United States, they're no longer teaching the scientific method. What they're telling students is that science consists of a number of facts that have been established by people much smarter than you'll ever be, and you should memorize them and repeat them. Now, in Massachusetts, for example, the science standards for high school involve the main assignment is to write your congressman or your mayor and tell them to get moving on climate action. That is a science assignment. Now, when children are taught this, they lose track of what the scientific method really is, which is to question everything and to be skeptical and to demand proof and to do experiments. And when your teacher tells you something, to say, well, why should I believe that? Let's go check it out against the empirical evidence. And that's not what we're teaching our students today.
You think modern day kids, though, might be getting smart enough or cynical enough to question this?
I hope so. I really hope so. It's hard to tell because the kids that answer the call to become climate activists, are pretty loud. And the other kids that are just happily studying their coursework may not be quite so vocal. So I'm hoping that that's true. But I think it's very important that we talk to teachers and we talk to curriculum managers and we talk to state politicians about making sure that we teach our children the scientific method. I have a colleague on the CO2 Commission named John Draws, and John has just achieved this in North Carolina, where after a long period of time, he got the people in North Carolina to change the high school curriculum to include the scientific method. So I think this is important. If you want to look at this, one of my favorite sources on this is the great physicist Richard Feynman, who used to say, science is a belief in the ignorance of experts. And we have to get away from this idea that we have a consensus on something, that we've had a committee look at it. We've written reports on it. These are smart people. They know what they're doing. And therefore, you should believe it too. Well, be skeptical.
That's a great advice. On one final separate note, you mentioned the scuttling of offshore wind plans because it doesn't make sense. Do you think there still are going to be people in the next few years lining up, politicians saying, let's do offshore wind because it makes so much sense?
I think fewer and fewer. And the reason is two things. First of all, the costs have just gone way up. And this is true for onshore wind, by the way, too. Supply chain problems, quality control problems. The big European wind farm manufacturers have gotten themselves in a lot of trouble with quality control issues, not being able to meet contractual commitments, costs going up, materials costs going up. The second thing is that people are recognizing that, particularly for solar, but also for wind, a lot of the components of these technologies come from places like China. And if you want to make yourself independent, putting up wind farms isn't necessarily the way to do it. The United States has really enormous reserves of natural gas, which is very clean. And we could run the whole country on our oil and natural gas without any difficulty at all and without any significant environmental problems. But the last point on that, Tom, is that every place that offshore wind has been tried, there's been a lot of local opposition. And the local opposition doesn't just come from people in the industry, it comes from environmentalists. We had a case, I live on Cape Cod in Massachusetts, and we had an offshore wind project that went on the books for many, many years here. And environmentalists were absolutely furious because they didn't want the pristine shores of Cape Cod sullied by these big industrial scale turbines. And the project never materialized. Now, I think what just happened in New Jersey is more likely to be the future. I think where people continue to try to plan these types of projects, both the cost and the local opposition are just going to drive them into the ground.
I'm glad to hear that. Any other points you'd like to make before we go ahead and finish this one off?
Well, the only thing I'd like to suggest is that climate change is largely a scientific problem, and people should look at the science, but it's also an economic problem. And I think people should just look at the economics of this. When we spend $1 trillion, that's $10,000 per family in the United States. And if you're spending that money and not getting any benefit at all for it, that's a terrible waste. And thanks, Tom, for inviting me onto the program.
All right. Thanks for coming on the program. I really appreciate it. This is great stuff. Bruce Everett. Talk to you later.
Okay. Talk to you later.